Hello and welcome to yet another video. And today we have an awesome board, like a ginormous one. We got an MSI Creator board, X299. So we have X299 Creator, as you can see. And this was sent in by a viewer. This board is enormous. And if I remember correctly, this thing has no reaction to the power button. Um, yeah, so I guess this is the power button right here? Oh, this is to set some mode. Interesting. So we do have a lot of different things. We have test points. We have boot LEDs. I really don't know what this dip switch here is supposed to be. We have postcodes. Board looks in fairly good condition. If it actually doesn't start up, I would expect there to be some knocked off components, especially close to the SIO. But we will see that. We will probably have to take a lot of these off, a lot of the shielding and everything. But let's now see for its passive power consumption. And if it reacts to a power button without a CPU in it. So let's see for its passive power consumption. So we have very, very little right now. It's only 20 milliamps. Let's see. Is one of these the power button? Doesn't seem to be. You cannot press this. Well, let me get a normal power button into here. And yeah, this should be our for turning on. Let's see. So we have no reaction. I don't know if it's supposed to be turning on without a CPU in it, because I'm not familiar with X299, how it's supposed to react to anything. Let's see if we have power at the power button. We have... I have a bad ground, I think. Let's get something that is grounded better. We have 3.3 volts. Okay, what do we have on the battery? We also have 3 volts. So the battery seems good, and we do have 3.3 volts on there. But let's turn this off. Let's get a CPU into here, because the owner of this board was kind enough to also include a CPU into here, so that I would be able to test this board. But the socket is very dirty, sadly, and we might have to clean it first. So let's get under the microscope and do that quickly. So let's see. There's what I've seen. This fuzzy skin here. Let's take that out of here. So that is out. Let me see if there's anything more in the socket to see. So that was basically it for the socket. We have a CPU here. Let's see. This is a Core i9 7940X. Yeah, we will not be able to read that. Let's see. CPU looks fine. So let's see. Which way is this supposed to go in here? Is it straight like this? Because I cannot see it. Oh, there's triangle. Okay, so it is upside down, like you had with X99 also. Okay, so close the socket this way first, then this, and now you can push these two down together. Let's first get this one. Yeah, now we have it. Now the socket is on. The CPU is in the socket. And let's see now if we have a reaction to the power button, if anything changes. Yeah, we have nothing. Okay. So no reaction to the power button. Let's check for our 3VSB if that is running. For that I always just use my PCIe tester, and it's not running. You can see it right there that the LED is not running. Let's see if what kind of resistance we have on our 5 volts standby. So that's the 4th pin from the top. That is quite low, 400 ohms. Okay. Let's see. So we right now have to find out why 3VSB isn't running. And for that, I want to first inject 5 VSB and see what kind of power consumption we get. For that, we need to find a good ground. I think I can use the PCIe slots for ground. No, I cannot reuse them for ground. Let me see. I think this socket should be grounded. Let me get something to inject voltage. And we have very low consumption. We have about 20 milliamps only. Okay, so I think that we don't have a short, but 5 VSB to but our 3 VSB isn't running because maybe a knocked off component close to where 3 VSB is being created. On many boards that I know, 3 VSB is somewhere created in this area right here. So we will have to take all of these shields off to see in those areas what we have there. We might also need to get a board view for this, but let's first just take these off and then see. So it's now partially taken apart, and we will now be having a look closer to here between those slots under the microscope to see if we can find anything that looks like 3 VSB. So we are close to the very lowest slot, and this is this one, and we're in between that and the slot above that. So far it looks fine. It's dirty, but it's fine. So these are PCIe capacitors. And let's see here. This looks like this could be the 3 VSB that should be created somewhere here. And you have this MOSFET right here. This often is responsible for 3 VSB, but the area looks fine. And now we are between the first and second slot. Okay, I hope this is, and this is just dirt. Yeah, this is not burned through, that's just dirt. Yeah, and it looks very fine here. We might need to look for some resistances there. This is, I think, around the Ethernet. Let's look around the SIO. Don't really think that the SIO will be responsible for anything here because the 3 VSB isn't running, and we will probably have to think about that first and see why that isn't running. Yep, see nothing. Let's go close to the 24 pin and see where 5 VSB is coming in and see if there's anything here. So we have 5 VSB coming in here. And let's see if we can see anything wrong here. If that might be the reason why our 3 VSB isn't running, but it looks fairly clean here. Don't see any damage. Let's go the other direction. Let's go down. So this looks like corrosion damage or something like that. No idea. Okay. No idea where that comes from. And there's almost nothing here. There's another controller, but this is not for our 3 VSB. It all looks like there's little bits of corrosion damage or like liquid damage, like here. But can't see anything that is decisively wrong here. So I haven't found anything wrong yet. Let's see for some resistances around what looks like 3 VSB for me. So let's use these posts, and there's an inductor here. This has 1 kilo ohm, this looks fine, and there's an inductor here. 430 ohms, that looks very similar to the resistance that we have on 5 VSB. That is even lower now. Okay, but that doesn't seem to be the problem. I will probably have to take off the other cover here, the cover over the PCH, to be able to reveal the area for the 5VSB where that also goes, to see if there's anything wrong there, because it could also be shorted into the PCH and that preventing the 3VSB from starting. So let's take that off and see. So the heatsink for the PCH is now off. Let's go for some resistances again. Let's see for the PCH. There are multiple inductors here. We're just going to test some. Let's see what this inductor says. And this says very, very low. That is not nice. This inductor says short. Basically dead short. That is not good. Let's see what this says. This is high resistance. This is good. And this is high resistance. And we have one more. This one has even higher resistance, if I get it correctly here. Let's go into a higher range. Yeah, this has high resistance. This has kilo ohms. So this sadly doesn't look good for our PCH. Not too sure what this voltage is exactly for, but it probably is something for the PCH. That is not very nice. There's another inductor here. Let's see. That inductor is 500 ohms. Okay. So let's get a board view of this and see what that inductor is responsible for, and if we actually have a dead PCH on our hands or not. So we have our board view right here. Let's get the multimeter out of the way. And let's see, it's this choke right here. Yeah, it's the PCH1 VSB line. That is not nice. Yup, pretty sure that this will be a dead PCH then. That this standby voltage rail is 1 volts, 0 ohms. That is very unlucky. So the PCH really only has this right here. That is not nice. We will be trying something. We will be lifting this inductor right here, and we will be seeing how the board reacts and on what side that 0 ohm resistance is. It's probably on the PCH side, but we will give it a last effort hope. So what we will do is we will get our... Let's now get a little bit of flux onto this side right here. And we need a lot of solder and we need a lot of heat. So we take our soldering iron and we're going to be applying a lot of solder onto here. We want to get this inductor lifted on this side. So just get a lot of solder onto here. And it's lifting, and there it is. Now it lifted. That is very good. And now we have the sides isolated. Now we get the multimeter in here again. So, and this is our side. And, yep, pretty sure it's the PCH. We have 0.6 ohms. On this side, we have high resistance. Yep, we have very high resistance on this side. I'm on 200 kilo ohms range, and it still doesn't show anything, and this is just dead short, sadly. We will be injecting voltage into that side, just to be 100% sure that it is the PCH that is dead. So we will be injecting 1 volt into that phase, and we will be using the thermal camera to confirm our findings. So with us having also lifted that inductor, we should be able to see some lights or something come on, or the 5VSB come on, because the short isn't there anymore. So let's see how it reacts now. Our passive power consumption is almost the same. And I still don't think we have our 3VSB then. Let me get my PCI tester and see if our 3VSB is running now or not. Yeah, it's still not running. The LED is still off there. So that is still not present, which is very interesting. But I want to focus now first on the PCH side of things. So we will be taking 1 volt. We will be taking our thermal camera. So we have 1 volt here. And I have the thermal camera. Sadly, my software isn't working right now, so we will do it analogly. And it's 4 amps, and yeah, you can see clearly right there. There's just one corner that is chipped off the PCH. It's getting a lot hotter. It really isn't that much. It really isn't that hot. Like, it's only 1.8 amps. Like, you can clearly see that heating up there. So I'm not totally convinced yet that this is actually dead. Because I would expect it, if it's actually dead, I would expect it to take 5-6 amps, something in that area. So we will continue on this endeavor. For now, we still have to find out why the 3VSB auxiliary isn't running. And for that, we will go into the board view again, and we will see where that gets created. Or let's even take the path of 5VSB and see where 5VSB has to go on this board. So we can easily start from the ATX power here. Okay, maybe not that easily. It actually goes to a lot of places at once. Let's see, capacitor, resistor to ground. Okay, nothing special. This is a controller, a S-media controller for the USB, so this isn't interesting to us. Let's see here. This is some sort of signaling, but yeah, this is for FV bus enable, something like that. Yeah, I don't think that this is important for us. Let's see here. This is 5 volts dimmed, so this is probably a linear regulator. It might be a P-channel MOSFET actually. But this is not what we're interested in. This might be a linear regulator also, or also a MOSFET, but I would be interested in this here, because this is our 3VSB phase actually. This is not shorted. This is its controller. There's the... no, this is a... interesting. This is a 5 volt dual. So how is this phase being created? Oh, it just probably comes out of this controller here. Okay, so we will have to see what happens. I will just inject 3VSB into here and see how the board is reacting then. And we need to see why this controller here isn't creating the 3VSB. So there's an enable signal that is coming from here. It's coming from the SIO that needs to create it. So we might, if that isn't present, we will have to take a look at the SIO area first. But let's see what happens if we inject the VSB into here. And I want to also then have a look at the enable signal of the 3VSB and see why that isn't coming in. So it is coming from 5 volt dual. So 5 volt dual should be first there. But let's check the things that we now have. We have 3VSB now on our tweezers, and if we inject it, I get 43 milliamps of power consumption. Okay, that looks fine. Let's also connect the 5VSB, and just to check, just to be very sure, you can now see we have the 5VSB connected. We have 23 milliamps. And if we have a look here, we have no voltage reading. If we check that, we do get voltage readings. So that isn't present. So let's now, with 5VSB also being present, let's see how this board reacts. So I don't see any LED indication, no lights, nothing. So I still think there might be actually something wrong with our SIO, because I don't think that the SIO enable signal is coming. that we saw on the 3VSB. But let's have a look at that. So we go under the microscope. So this is our 3VSB controller right now. And we should get an enable signal. I think it was on this transistor right here. And we don't have that enable signal. So let's see here. This is, I think, coming from... This might be the SIO enable signal, which is 5... Oh, you cannot see that. Let me do that again. Get the multimeter into here. So, to show you again, we don't have 3VSB, which is still 0. And when checking this, we have 0. This lower one has 5 volts. And this upper one has 0 volts. Okay, so let's see now what that corresponds to on our board view. So we know our enable signal is low. Our gate is the SIO SLP sus, which is high. Interesting. So I think that isn't supposed to be that way. We will probably need that enable signal. So we have to check what is connected to it. We have a resistor. No, this is not connected. Okay. Not quite sure. Oh, this is a diode. Okay. Interesting. SPI switch select. Okay, so this is for the BIOS chip selection. What is this? This is also BIOS switch. Okay. Then let's see. We have one resistor to 5 VSB connected right here. This should be this is in place because we do have 5 volts here. And let's see, this one also takes that onto gate as 5 mod. Okay, the question is now why I think this shouldn't be present. Because why is it pulling the enable signal low to ground then? I do have a schematic for this. Let's have a look at the schematic also. Q59 we will have to look at. So let's have a look right now. So we can see Q59 right here. And if I understand this correctly, this N-channel MOSFET here pulls the 5 volt dual, that is the enable signal right here, pulls it low with SIO SLPS sus. So this is not supposed to be present in order for us to get the 3VSB enable. So we will have to look for this signal and see why that is present. So we have the first instant of this is on our SIO, and it's a actual incoming signal, so it doesn't come out of the SIO, but it goes in, as you can see by these two right here. This goes into here. So this is a power fault signal. I had these before, that there was a knocked off resistor that triggered a power fault condition, where then the power button couldn't be, where the PS on actually had a transistor before it, where the 5 VSB couldn't be pulled low because of power fault was enabled, just like here. So let's see where that comes from. Here, R510. So we will have to take a look at this resistor, especially if that is there or not. Let's see what also, where it also comes from. There's a diode from ATX5 VSB. So we will have to check that D27 also. This goes into the SPI switch select. Let's see what else we have. This is also an incoming signal for some sort of controller. PEX BIOS. Oh, this is for switching the BIOS also. And let's see what else we have. We have the enable for 5 volt dual. So 5 volt dual is also not present on this board. That's why we have that low of a power consumption. So the S5 mode turns this down probably as well. This is like a enabled signal right here. And it also, this SIO SLPS sus pulls the 5 VSB that's coming into here to select the mode also down to ground. so that this also doesn't turn on. And the last one is the instant that we were looking at for the 3 VSB. So let's go onto the board and find R510. So, and we have R510 right above the SIO. So let's have a look at this right here. So we are close to the resistor. And is it this one? 5 volts. Yep, 5 volts. So we have checked. This resistor is in place and we have 5 volts on both sides. So that isn't our problem. Let's now search for, I think it's called D27 it was. It should be this one, yeah. Let's see for this now, if anything is wrong here. Let's go into this area now. So let's now check what we have on this diode right here. It should be the furthest left one diode, which is right this one. We do have 5 on this side, and this should be just 0, right? We also have 5 on that side. Interesting. Let's check the diode. If like the diode is faulty, maybe. Let's see now. We have turned it off, and we have high resistance. Let's go into actual diode mode. Yep, 0.3 looks fine, and in the other direction also looks fine. So yeah, so all of that is fine. So why do we have that fault state? Let's switch this power switch, and that does also nothing. Trying to switch this into any direction. And I found something on the backside, which looks like a knocked off resistor. So let's see what this was responsible for, if my theory was correct about a missing resistor for the power fault. So let's go into the board view. And it is at the very top here, which is this resistor, which is a 10K resistor, which connects to 3 VSB. Which is weird, because we don't have 3 VSB yet. I don't like this. And this ends up... in what kind of signals does it end? Rush HK VSB, so I don't know what that is supposed to be. And it also goes... yeah, that's the only thing. Oh, and OC5. Which goes also connected to 3 VSB. Which is connected to the PCH also, and to this 10K ohm resistor. And here on this double N MOSFET we have 5V R USB 1. So I don't think this is actually our problem, to be honest. I think because this would come after. This actually comes after 3 VSB. Because I don't think that this will be giving out a fault signal anywhere, which would trigger that the SIO to not give out the power OK signal or the SIO fault. So we will be placing that 10K ohm resistor, but I don't think that this is actually our problem, sadly. So I've put that 10K ohm resistor in now. Let's supply voltage again. I don't think that this will actually change something, but let's try it. So let's now supply voltage. And we have no change. As to be expected, because like I said, this is something that is later than 3 VSB. So we're looking for something that is responsible for enabling 3 VSB, like the power fault, and this was something after where 3 VSB is coming on, and we would need that later. It's important that we found that, and we now definitely know that we have to look for further physical damage to find that, but I will be doing this off screen because this board is just huge and enormous, and it will take quite some time and fiddling around to find it. So let me continue to search for that. So this board had definitely water damage. As you can see, all of this area right here has been cleaned before. which you can clearly see. And following the trace of all of this being water damaged, I found this right here, which is a very corroded area. Let's see if we get any short circuits on this here. So, checking these capacitors. But it doesn't seem to be shorted in any way here. So, none of this is shorted, but I will definitely have to clean this up. I had no idea that this board had physical damage before, water damage in any way. And I'm not too sure if the owner knows that. So I will have to clean this up because this is old damage. Like when it turns green like this, it must have been on there for quite some time now. So this cleaned up very nicely. But the following phases are also very corroded. Like at least 2 here. So I will have to check them first. I want to see if any have any shorts, and then I will clean them as well. So just for reference, even the V-Core VRM has slight damage. So signs of corrosion also, very sadly. So I've spent a long time now trying to figure out what is wrong with this board, because we still have the situation that SIO SLP sus is our big problem. Why our board is not turning on, why we don't have 3 VSB, 5 dual, and so on and so forth. And going into the schematic now, going through it together, SIO SLP sus is an incoming signal into the SIO. Further, we have a pull-up resistor to 5 VSB, so that's the 5 VSB that we have. Then we have a diode that goes to the SPI switch select. And let's skip this. This is the important. This is one of the important. This is an enable signal for the 5-volt dual that is coming in here, and it's currently pulling the 5 VSB for mode down, as we talked before, and also it's pulling down the 3 VSB that is coming out of this controller right here, where it should be the enable signal. The 5-volt dual is being pulled low right here. So the only way SIO SLP sus is being pulled low is by this thing right here, U78. This seems to be some kind of switch, which also puts the RST low, which is for resetting the SIO, and this is the main BIOS switch, and it is connected through R792, which is just a shorted resistor, and there's a bleeding resistor for the gate right here just. So we want this output to be high. This output is supposed to be pulled. If this output is high, the gates is being enabled and SIO SLP sus is being pulled low to ground, which we want, so that everything else is being enabled. So we will have to take a look at this switch right here. So this is a programmable input-output switch that is once fed with SPI VCC3 and also by VCC3, which we do know that this isn't present before because this is the 3 volts. But SPI switch in could be present, and also SPI VCC3. So we would be needing this input right here because the other input is definitely low. And this SPI switch only goes to the SPI select. And the SPI select is a little bit more complicated. it comes out of the PCH, which is the most important thing. You can see PCH. It comes out of here. And this SPI select, which is the most important, then goes onto the switch, and this would connect B with C and supply the SPI VCC3 as well. And the SPI VCC3 is what we would need for this switch that we had before. And this would be where it would end up. So this SPI VCC3 would give the voltage to this controller and would also be the SPI switch in at the end, and then pull our output low. But there's a fault condition on this board, and I will show you what exactly that fault condition is. So we now will be pulling this SIO SLP SAS low by ourselves. So we will be pulling this transistor low, so high. This NPN transistor is going to be, we're gonna give the gate voltage, so it's going to pull SIO SLP SAS down to ground. So let me show you what happens then. So I currently have a resistor right here to my pliers, and that resistor is going to ground. And now with these tweezers, there's a transistor right there where SLP SAS is located. And I will be pulling that SLP SAS now low by myself, and look at what happens with the power consumption. The power consumption of the board climbs to 1.3 amps. So now the board starts up and actually puts out some voltages. We can probably see that. Let's see if the tester also shows now 3 VSB being on. Yeah, now the green light on the 3 VSB is on. But we have a big problem with that, which is our PCH that we were looking at before. So let's have a look with my phone now. If we now go onto the PCH and we now pull it low, we get almost instantly 85, 90 degrees, 92 degrees, a big hot spot right there. It's now almost at 100 degrees already. Let's see if I can go down with my camera. Show you that a little bit better. So have a look again. Sadly hard to see on my phone through the camera, but it's already at 100 degrees now. Yeah, 99, 100. Yeah. So this PCH is definitely dead, which was really, really hard for me to diagnose. Like backtracking why our 3 VSB wasn't starting and why that SAS rail was on the whole time was so difficult, because the PCH needs voltage in order to enable the whole SPI area, which means the selection of the BIOS happens with as soon as the PCH has voltage, and it then creates what is needed for the 3 VSB to go down at the 5-volt dual by selecting the BIOS and then going from there. And finding all of this out, because these signals go into different switches, they transform multiple times, just where they go through a bridge and then they're called something else, was just so confusing. And I'm pretty sure I didn't understand it to the very end 100%, but I now definitely know that this PCH is dead, because we had the 1 volt there, but as soon as it gets enabled by all of the other signals as well, it really shows how shorted it is, how bad this is. So this board needs a new PCH to work properly. It just with voltage injection, we weren't able to see how badly shorted it was. But now with pulling the SLP SAS IO down to ground, we actually were able to see how bad that short circuit is. And yeah, this is sadly gone for. And yeah, I've never had it so difficult to confirm a dead PCH. Like, the amount that it heated up when we injected 1 volt here really wasn't that much. But as soon as we got the chain of the other standby voltages working, we truly were able to see how bad the short on it was. And it just threw me for a loop so badly to find out how this all worked. Like, imagine if I didn't have a schematic or a board view. This would have been just bloody impossible. Like, even with that, it was so hard to understand, and I don't understand it fully to the end. But with that, I was able to trace it down and at least go to that signal that I really needed for the 5 VSB and the 3 VSB to pull that low, to get all of the other chains on this board working, to find out that this PCH is just done for, sadly. I'm very sorry for the owner of this board. This is a great board. Maybe he will be able to find someone who replaces that PCH, because I'm pretty sure this board is very well worth it to do so, even though it has awful water damage. Like, I don't know how, I'm pretty sure the owner doesn't know of that, but especially this area at the top left and the VRM area had awful damage of the some sort of liquid, and that might have been the cause at the end why the PCH went. Don't know, because at the backside there was also some areas that had damage, water damage, but who really knows what happened to this. But I hope you learned something. I hope it was I hope I was able to make it somewhat understandable what has happened here, because I stumbled about with my own thoughts multiple times when trying to diagnose this. But I hope you enjoyed it, hope you learned something. And yeah, thank you very much. Thank you very much for the one sending this board in. I will sadly be returning in this without a fix to him. But yeah, that's what sometimes happens. Thank you very much for watching. This was Mainboard Medic. All of my tools are linked in the video's description. Thank you very much, and goodbye.